Hello, this is lesson 5.01. We're starting a new packet or a new chapter. We are doing skeletal tissue. So we do the skeletal system over two chapters. In the first one, we talk about some of the physiology of the cells in the skeletal system and how the bones are made up and in terms of their structure. And the second one, we memorize bones. We do the axial skeleton. You memorize all the bones in the axial skeleton along with all of their landmarks. So most of our physiology comes in this chapter, and the anatomy will be in the next chapter. And like we do with most systems, let's talk about an overview of what this system is responsible for and what it does for us. So how many functions can you think of for our skeletal system? I'll pause for a second. Hopefully one of the ones you thought of right off the bat was, looks like I've got a dead pen, is protection. So your skeleton and the bones in your skeleton protect you. Let's try this guy. There we go. So what are some of the bones that offer protection? Your skull protects your brain. And we're using skull as a general term. We're going to learn there's like 20, 23, 24 bones in the skull. You'll learn each of those. But for now, we're just going to call it the skull. Your rib cage protects your lungs and your heart. Did you think of support? Your skeleton is what gives you the rigidity to be upright. Other organisms use different schemes for this. Insects have an exoskeleton, so their skeleton's on the outside. Plants have cellulose, but for animals, we all have what's called an endoskeleton, where we have bones on the inside. I should say for not necessarily for all animals. That was a really wrong statement. For chordates. So all of the chordates, if you have a backbone, for the most part, you probably have a skeleton. Believe it or not, we need our skeletons for movement. Now you said, wait a minute, that's muscles. Well, the muscles don't work unless they have something hard to attach to that act as levers. And so our bones, the muscles actually supply the force. The bones operate as levers. And one of the reasons why if you're going to be a physical therapist, you have to take a lot of physics, is that you have to understand levers and torque or a physics topic. And that's all that muscles and bones working together pretty much are. So there's a lot of physics in that. You might have gotten these three, but the last two aren't quite as intuitive. Red blood cell production. That occurs in the red marrow of our bones. And we're going to put some bullet points here. It occurs in the red marrow, which is found in the middle of long bones. Well, it's found different places in different ages. So when you're a baby, it's found in your long bones. And we haven't talked about what long bones are. That'll come in the next chapter. Long bones are bones like your femur, your humerus, your tibia, your fibula, your ulna. But as you age, red blood cell production, which by the way is called hematopoiesis. Try to say that, hematopoiesis. Hemato is one of the terms we're going to use for blood. And poiesis is forming or making. So hematopoiesis is blood forming. In babies, it's taking place in long bones, but in you guys and in me, our red blood cell production, and if we were talking about red cell, specifically here, we said red blood cell production, that's going to be erythropoiesis, referring to the red blood cell. And we've had the word erythro before. So this is talking about kind of the whole, all of the aspects of blood. This is talking about red blood cell production. But in young adults to adults, your hematopoiesis and your erythropoiesis it shifts. It doesn't happen in your long bones. In fact, we're going to look at a long bone 2 lessons from now, and we're going to see that it's filled with actually a yellow marrow, not a red marrow. Well, it's because for whatever reason, it shifts. And in adults, it takes place in the vertebra. Can't talk this morning. The sternum, and in the top of the pelvis. We have some limited red blood cell production in the ends of our long bones in the femur, and when we look at the diagram of the femur, we'll see that. But for the most part, your vertebra, your sternum, and the top of your pelvis, if you've ever had ribs, you know that when you, like baby back ribs, if you crack open the middle of the rib, it's got that dark, it looks like a black marrow. It's red marrow, but after it's cooked, it turns dark. So we kind of have seen that before. And the fifth, and I don't think anybody ever gets this one, your bones provide your calcium storage. You have got to have calcium. You need calcium for contracting your muscles. You need calcium for your nerve impulses to carry. If you don't have calcium, you're in a lot of trouble. One of the things that's interesting is women who are pregnant, if they don't drink enough milk and take prenatal vitamins and get enough calcium, the fetus will simply just dissolve calcium out of their bones. And pregnant women can be more prone to broken bones if they don't get enough calcium. Well, how does your body do this? And what we're going to see is this calcium storage is part of a negative feedback loop. We've talked about this earlier, and you may have even done a reading assignment on feedback loops. There's 2 kinds of feedback loops. There's positive feedback loops and there's negative feedback loops. And calcium regulation is part of a negative feedback loop, and it regulates both. If your calcium goes high, it kicks in, and if it goes low, it kicks in. Well, the gland responsible for this, and I'm going to draw, let's see, let's get ahead here. Oh boy, I'm drawing. So we need a person and we need a neck. So in your neck, you have, I'm going to do this in red, pink, blue. You have a gland, and it looks like a butterfly, a little bit, or a bow tie, called your thyroid. Your thyroid gland. Right on top of the thyroid, on the 4 corners, it's like you've got 4 dots on your bow tie. Here, 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 here. Those are called the parathyroid. Your parathyroid glands. And we're going to give you kind of just the broad strokes here. We're going to spend at least 1, maybe 2 lessons talking about this feedback loop. So if your blood calcium is low, so if you're, and it's your pituitary gland that turns these off and on. So if your pituitary registers low calcium, and calcium, I'm going to write that as Ca+2 because that's the form it floats around in our body as. And this is in your blood. So you always have calcium floating in your blood so that it's available to you. So if your pituitary registers a low calcium level, it will cause the parathyroid to release a hormone called parathormone. Parathormone. This is more commonly called PTH. Remember, feedback loops keep homeostasis, and you need your blood calcium to stay at a certain level. So if it starts to go too low, your pituitary will say, okay, parathyroid, release this hormone. And what this does is it triggers a cell in your skeletal system called an osteoclast. And the job of osteoclasts is to dissolve bone. Well, if you're dissolving bone, you're also dissolving calcium. And so this releases calcium into the blood and raises it. It releases it into the blood and it raises your level. But it doesn't always necessarily go low. Sometimes your calcium level gets too high. So you eat a banana split and you wash it down with a big glass of whole milk. So maybe your blood calcium level is too high. So when that happens, the pituitary gland registers again that it's too high. So this time it triggers the thyroid. And the thyroid releases a hormone called calcitonin. The calcitonin goes out into the blood, it courses through the blood, it gets to the bone, and there are a second set of cells that live in your bone called osteoblasts. And these guys lay down new bone. And so what's going to happen is as they're laying down new bone, they're pulling it out of the blood. They're pulling calcium out of the blood to put into the bone. And so this drops your calcium level. So this is just kind of an overview. We're going to go over this again in a lot of detail later, but calcium storage and I would say homeostasis of calcium. Let's add that. That was a telemarketer. Sorry about that. So we have homeostasis of calcium, would be another way to say this. So these are all of the things we're pretty much, the only one we're going to talk about in more detail is here, and these are pretty straightforward. So again, our takeaway is this was our introduction to the skeletal system. It'll be the first of 2 chapters. All right, guys, thanks for watching and have a good day.